The colonization of Titan, Saturn's largest moon, is a concept that is currently more theoretical than practical, but it has garnered significant interest from scientists, space agencies, and futurists due to Titan's unique characteristics and potential for supporting human life, at least in a limited capacity. Here's a detailed breakdown of what a potential colonization of Titan might involve, considering its environment, the challenges, and some of the current ideas and research related to such a mission. Titan's environment. Titan, Saturn's largest moon, is one of the most Earth-like bodies in the solar system, but it also presents significant challenges for human colonization. Atmosphere. Titan has a thick atmosphere, primarily composed of nitrogen, about 95%, with small amounts of methane, about 5%. The pressure at the surface is 1.5 bars, which is about 50% greater than Earth's atmospheric pressure, so humans would need pressurized habitats. The atmosphere also has clouds and a weather system, with methane rains and rivers, creating an environment similar to Earth but vastly colder. Temperature. Titan is extremely cold, with average surface temperatures around 290 degrees Fahrenheit, 179 degrees Celsius. This is far colder than anywhere on Earth, so any colonization would need to address extreme cold. Surface. The surface of Titan is mainly covered in vast plains of organic-rich compounds, dunes, and lakes or seas made of liquid methane and ethane. It has a solid icy surface with a rocky core, and it is believed to have a subsurface ocean of water beneath its icy crust. Gravity. Titan's gravity is about 14% that of Earth's, which means that moving around would be easier than on Earth, but without a pressurized suit, humans would face significant health issues due to low gravity over long periods of time. Challenges for colonization. Colonizing Titan would be an immense challenge due to the combination of harsh environmental conditions, technological constraints, and human physiological needs. Some of the main challenges include atmosphere and oxygen. Titan's atmosphere is not breathable by humans, so any colonization would require self-sustaining habitats with a life support system that could produce oxygen, remove carbon dioxide, and protect from dangerous gases like methane. Temperature and energy. The extreme cold would make it difficult to keep habitats warm enough to sustain human life. Solar energy is not an effective option due to Titan's distance from the Sun, about 10 times farther than Earth's distance. So alternative power sources like nuclear reactors or radioisotope thermoelectric generators, RTGs, would likely be required. Radiation protection. Titan does not have a magnetic field, and the atmosphere is not thick enough to shield from cosmic radiation and solar particles. Colonists would need radiation protection, such as thick habitat walls or underground structures, to ensure safety. Transportation and mobility. Titan is located in the outer solar system, requiring long-duration space travel to reach it. This would need highly advanced propulsion systems capable of transporting humans and equipment across vast distances. Currently, the journey would take several years with current technology. Possibilities for colonization. Despite the harsh conditions, there are a few ideas on how colonization could work, assuming technological advancements and long-term investment. Habitats. Early settlers might live in enclosed, pressurized habitats or domes. These habitats would need to be insulated to protect from the extreme cold and to provide necessary life support functions like air circulation, water recycling, and food production. They would also need to be sealed to prevent the toxic atmosphere from entering. Energy sources. Given the lack of sunlight and Titan's extreme cold, nuclear power would likely be the most reliable energy source for human colonization. RTGs, used in spacecraft like the Voyager and Curiosity rovers, could provide power for habitats, rovers, and other equipment. Solar panels might also be used for small-scale operations but would be insufficient for large-scale needs. Resource utilization. Titan is rich in hydrocarbons, particularly methane and ethane, which could be used as fuel sources for energy production or even propulsion. This could make Titan a useful base for exploration beyond Saturn's system. In situ resource utilization, ISRU, could help reduce the need for frequent resupply from Earth. Living off the land, Titan's surface is covered in organic compounds, so one potential approach could involve producing fuel, food, and building materials from these chemicals. Methane and ethane could serve as both energy and raw material for other processes. Water ice mining. Water, which is critical for human survival, is available on Titan in the form of water ice. This could be melted and purified to provide drinking water, and possibly used in creating oxygen. Furthermore, extracting hydrogen and oxygen from water could help create breathable air for habitats. Titan's lakes and seas. The liquid methane and ethane lakes present unique opportunities. While these liquids are not useful for drinking or growing crops, they might be valuable for chemical processing. Future technologies might also enable the creation of habitats or platforms floating on Titan's seas, though this would be an incredibly challenging engineering feat. Timeline for colonization. While current space exploration programs like NASA's Dragonfly mission, launching in the 2030s, will explore Titan and gather valuable data, full colonization is still a long way off. Some estimates suggest that we may not have the technology or capability to seriously begin colonization efforts for several decades, potentially well into the 22nd century or beyond. Short-term. Initial missions could involve robotic probes and scientific instruments to learn more about Titan's environment. We could also see unmanned missions that deploy rovers or drones to explore Titan's surface and atmosphere in greater detail. Medium term. We may develop the ability to send humans to Titan for extended stays, much like we have on the International Space Station. These could involve missions focused on scientific research, resource exploration, and testing of life support systems, perhaps living in self-sustaining habitats for months or years at a time. Long-term. Full-scale colonization would likely involve large-scale infrastructure, including multiple habitats, power systems, life support systems, and ways to produce food. It could take many decades or even centuries to develop the technology and infrastructure for a permanent human presence on Titan. Key missions and current research. NASA's Dragonfly mission, 2030s. This upcoming mission will send a rotorcraft lander to Titan. Dragonfly will conduct a series of scientific experiments to study Titan's atmosphere, surface, and prebiotic chemistry. While not a colonization mission, it will provide valuable data that could inform future missions. ESA's Titan Explorer concept The European Space Agency, ESA, has considered sending an orbiter or probe to Titan to study its atmosphere, surface, and potential for life. This would help scientists learn more about the conditions that could allow for human exploration. SpaceX and other private companies. While SpaceX is currently focused on Mars, there is a possibility that private companies may eventually look to Titan as a future destination for human colonization, driven by commercial interests and the potential for resource mining. Conclusion. The colonization of Titan would be an incredibly ambitious and long-term endeavor, requiring vast technological advancements in space travel, life support systems, resource utilization, and energy production. While it's not something that could realistically happen in the near future, Titan's unique environment presents an intriguing opportunity for exploration and potential colonization in the far-off future. The exploration of Titan in the coming decades, particularly with NASA's Dragonfly mission, will provide critical data that could lay the groundwork for future human presence on the Moon.